Welcome to a new test and teardown video. This time it's something completely different. I found this unit down in the electronic waste the other day, and I just couldn't figure out what is this thing doing. So I just took it home just to see if I could figure out what it is. From looking at it, I didn't figure it out. I had to Google this. So let's see if you can play around, play along. I mean, I'm of course going to just write it in the description so you will know. But I think you can see why I didn't figure it out. There's a big hint here. The little glasses, and then I think this button here is not working because, see, click, click. Those do the clickety click, and then there is, yeah, you see there's probably something broken here, but I guess the idea is you can open this and then you should be able to close it again, right? So you put in your glasses, or your frame for your glasses. Obviously you cannot have the glasses mounted, but let's imagine you have the frame without the glasses, and this is what your customer buys. So I think the idea is you stick it in something like that, clickety click, and then there's this little sensor here, as you can see, this little metal sensor here. I think the idea is this goes around all the way in the frame and carefully go to the other one, and then measures the perfect dimensions of the glass that you need to order for your glasses, right? And it will do this scanning in 3D, because as you can see we got some different angles and all that kind of stuff. So this is, yeah, a frame tracer 3D scanner, something like that. And why is this in my normal e-waste? That is something really weird. You can print out something, you can do the left or the right or both, and I don't know what that kind of recording here is doing. And I should show you the rear side. It's full of connectors. It's really heavy, and it's quite big, and there's a fan in there. There's a little extra thing here, and then look at the back. We got 4 sub D9 console, barcode, some etcher 1 and 2. And of course it's called this HFR 8000, a frame reader. I found some web pages with some pictures and some information explaining exactly what it is and how it does this and that. I should probably put in a few snips from the web page so you can see what kind of information I could find. I think it could be fun to see what is inside. Of course, I can't use it for anything. Maybe we should just see if it blows up. That could be funny. Okay, so let's just power it up and see what happens. It's using only 7 watts. It looks moving around. Can you hear it? Chickity chockity. I really would like to see what is it's doing. So it's writing. What are you writing? What the heck? It's ready. So I mean, maybe you can. Let's try and do the left. Let's pretend we put in something. Oh, moves the scanner. It goes up. Ooh, it hits this. Ah, it goes really tight. Oh dear. System error, obviously. So it moves to this stop, and then it hits that stop, and then it says error. Check the movement. Okay. So maybe I just click. How do you... so this is probably the stop. Check the... How do you... See, that button here is not working. This one is also not. Yeah. Ah. Oh, you can. No, you cannot. Yeah, the problem is, of course, with the... I want to try again. So this is a new initialize. Oh, it's moving. Oi, oi, oi. And then it's going. Oh, it can also move these little things. And then it says ready. So now you go these. So the idea is, I'll try and put in some stuff. Let's just put a battery or something. I don't want these to be in the way. And then let's try and start. Aha! It hits this way. So it goes. There you go. Boing, boing. Check the frame. Continue. Where's continue? I don't know what to continue. Ah, now this switch works. Ah! I think it's quite funny. Yes, definitely. Of course, I don't have the glasses without the frame without glasses, so I don't know how to do it. But it says something about it can scan metals. So how is this sensor thingy here checking its metals? Well, I didn't really expect to be able to use this as it is, so, and I don't have anything to use it for, but at least it looks like it's alive. But what I really wanted to do is I wanted to open and see what kind of cool things is inside. So that's what we're gonna do. I'm a little bit impressed. It's really a mechanical marvel. I mean, look at that. So here's the interface cable for all this stuff that's going on here. The cable goes here and then there, and we got some wires twisted like that. So this one can rotate. This is that motor. It's connected to the outer part like that. And it can obviously continue and continue. And then there is this piece here that can move back and forward. I don't know, how can I show this? This one. And then there is, I will probably have to take it a little bit more apart, but there's another one that goes up and down as well. Let's see, how can we show that? And then this whole thing can also move using that motor. Oh my goodness, and it's really made, I mean, rock solid, stable. And tons of sensors and bearing. Good grief. This is nice. And there's even a big, heavy... I mean, this is probably to make the steps on the motor nice and smooth. So instead of using a micro-stepping driver, then add this mass to the stepper motors. That is a little bit weird. But anyway, oh yeah, here it is. Here we can see this little sensor thingy that moves. Oh, I can't reach it. Maybe I can do it with this one. See, here we go. So this one moves up and down as well. So how is it sensing when it hits something? I haven't yet figured that out. Let's try and pull this apart a little bit. So the rotate step motor here is connected, and this super flexible goes, of course, via this hole to that connector. It's supposed to be some sort of a stop, right? Ah, here we go. So it goes to that click, and then click the other way, block. Okay, but then it don't know. Here there's no sensor, it's just gonna be blocked. Maybe there's another sensor somewhere. Yeah, let me take all this away. Here is just interfacing for all the other motors. They don't really talk about any kind of sensors. So where is the... So, oh, it goes out of the... Can you hear? Gear. And then this. I don't understand how this measures. Oh, there's a little encoder. So one is the motor and the other one is the encoder or something. That is nice. Let's see what else we can do here. How can we get this? I want to take the outer shell away so we can see all the neat things. So inside the front panel we got a normal 2-line display and just the different switches and all that. It's not super important. A little cable and a little EMC filter. That is, yes, that will be the main power supply that is located here in the front. And the rest of the case is just plastic like that. So there isn't any radiation shield or anything protecting this. And then we got this fancy solution here with little wires. Oh, that is really beautiful. So the steel wires goes around in a loop like that. And I believe this stepper motor here, when this moves, it rotates this one. And look, there's a groove. And when this is rotated, it probably locks these and hold the glasses. And then we got some sensors here for close and open. And there's another one right there. What is that sensing? Ah, this is sensing the lock. Okay, so there's an end stop on all the different stepper motors. They can move until stop. And we got some more. Yeah, let's try and see if we can take all this away so we can see some more. What a beautiful piece of engineering. I can now show you some more. So, it's right, these are moving. Remember, we also saw these little parts here moving. So the idea is, when the stepper motor here moves, see, it locks, and then it transfers this rotation via the steel wires to this system pulling in here. Now you can't move anything. So let's try to do it the other way. See? A mechanical masterpiece. Nice. So behind this little extra isolation shield, I don't know exactly what is the point with that one. We got this little switch mode power supply from Meanwell. How nice. We got 4 wires coming out of this one. I'll probably see if I can figure out what kind of voltages is it's generating here. Let's see. Yeah, there's always a little sticker on the Meanwell power supplies, and it's hidden right here. So it's a plus 5 volt, 5 amps, and 12 volt, 2.8 amp. That is actually quite a lot, 65 watts in total. And they use the same board here for the 3 voltage output, but the last output here is not populated. Why is it so out of focus all the time? So removing the metal bracket that holds the power supply, now we can see the main controller board, and it is really, really beautiful. The main brain is a Samsung ARM. Tons of flash, RAM. Really? So that's also necessary. And fast FPGA, port expansion chips, and motor drivers, and some more motor drivers. We of course got quite a lot of DC motors and stepper motors all over the place. So, oi, look at that cute little, what is that? We better go and have a look. So it says something about 64 kilo. That's a little bit interesting. All the end stops, they are using 3 wires, and that's because it's active sensors. So there's a little light emitter and a little light sensor and a little level translator transistor. So for, I don't know exactly why. And one of the sensors, that's just 2 wires, and that's because it was this one only a micro switch. So I pulled out this little I2C EEPROM. Look at that. So it's for configurations. Isn't that cute? And then JTAG connector. That's also a little bit nice. This is a little bit interesting. So there's a connector right there. And look, it says image. Where's that one going? Let's have a look. So the connector with image just goes to the rear panel with the 4 sub-D connectors. I mean, why is that called image? I think we can see a lot more what is going on here. Beautiful mechanical solution. And there we have it with this one. What is the point? So it's just using the motor and some I really don't want to touch that one. Oh, we got some screws like that. It looks like 3 screws, but I can only see 2 heads. That's probably a set screw. So that is to create the low friction. So the end stop switches, I mean, we're using cables with one type of connector in one end and another connector in the other end. Snippity snip in here. And here's the funny thing. Tiny little screws right there, easy peasy. But how do you put in the screws there? Because look, they touch each other. So you can't put those in, or you can't put those out. I already tried this, just so, see, if I try to, see, maybe in this one, you can't really get in without bending the board. I don't know how. So now, okay, now you can move it. So now it's probably possible. That is not so smart. And we got plenty of space here to put that screw here. And they could have been in like here and here. Bada bing, bada boom, it would have worked. That is something they are definitely not proud of. If you ask their production line, they would say, oops, that is not goody goody. So I was able to remove all the cover plates, and now I can see much more clear how everything moves around. The only thing that you need to imagine, that is this entire sledge here can also move left and right. Of course, over the rotation, and then there is this up and down, and also this one can move. So that is how it can do all its fantastic things all together. Yeah, I'm actually quite impressed about all the mechanical little thingies in this unit. I think it should cost a fortune. All the design and all the, assembly of all these little thingies, it must take forever. So it's definitely a really fantastic product. And I think that is all I wanted to show you in this video. So thank you very much for watching, and please come back again soon. Bye bye.